Hey guys, I hope you're home safe. This is going to be a series of 4 videos on rational expressions, and today we are simplifying rational expressions. Hey guys, and welcome back. If you haven't done so already, go ahead and subscribe to my channel so you don't miss any future videos. In this video, we're going to be talking about rational expressions and how to simplify them. As a reminder, a rational expression is defined as a quotient of two polynomials, but unlike polynomials, they do not exist everywhere. What I mean by that is, remember that an algebraic expression is made out of numbers and variables, and those variables are just letters that are sitting in for numbers, and a polynomial can be evaluated for any number you put in for the variable. But that's not true for rational expressions because they have denominators. And we all know we can't divide by zero, at the risk of causing the universe to implode upon itself, ending all life, and that would be worse than Thanos snapping his fingers. And so the domain for a rational expression would be all numbers that do not make the denominator zero. Let's look at a few examples. The first example is going to be 7 divided by x minus 3. And so looking at this, what number would cause the denominator to be 0? Since the denominator is x minus 3, the number that will make it 0, it's going to be 3. And so the domain for this particular rational expression will be all numbers except 3. The second example is going to be x plus 1 divided by x squared minus 25. Now, looking at the denominator again, if you remember, this denominator is a quadratic, and so you can rewrite it as x minus 5 multiplied by x plus 5. And so what numbers can make this denominator 0? This denominator can be 0 if either of those factors are 0. So you would not want x to be 5 nor negative 5. So the domain for this particular rational expression will be all numbers except plus or minus 5. Third example, x squared divided by x squared plus 1. Now looking at this, what you want is x squared plus 1 to be not equal to 0. And so that means that you want x squared not to be equal to negative 1. And so looking at this is always going to be true because x squared is always going to be positive. And so there's no chance for the denominator here to be 0. So the domain for this particular rational expression will be all real numbers. All right, how do you actually go ahead and simplify a rational expression? You can do that in 2 steps. The first step is to factor the numerator and denominator completely, then divide out any common factor you found. So let's look at an example here. The first example will be 3x minus 9 divided by x squared minus 6x plus 9. Now looking at the numerator here, you should notice that the numbers in those terms have 3 as a common factor. And so you can pull out the 3 from those terms and rewrite this expression as 3 parenthesis x minus 3. And so the denominator here, for the denominator, you are looking for 2 numbers that are going to be adding to negative 6 and multiplying to 9. And the 2 numbers here are going to be negative 3 and negative 3. And so you can factor this denominator as x minus 3 multiplied by x minus 3. And so with that, this is completely factored. And so now you can go to step 2 and divide out any common factor. X minus 3 and x minus 3 are common, so that will go away. And all you have left is just 3 divided by x minus 3. And just as a side note, the domain for this particular rational expression would be all numbers except for 3. Next example, let's look at y squared minus 4y minus 5 divided by y squared plus 5y plus 4. And so the first one here, the numerator, you're looking for 2 numbers that would add up to negative 4 and multiply to negative 5. And that's going to be 1 and negative 5. And so this could be written as y plus 1 multiplied by y minus 5. And for the denominator, looking for 2 numbers that add up to 5 and multiply to 4, that's going to be 1 and 4. And so you're going to have here y plus 1 multiplied by y plus 4. And so simplifying the y plus 1 on both numerator and denominator, you're going to have left y minus 5 divided by y plus 4. Now for this particular example, the domain is going to be all real number except for negative 1 and negative 4. Whenever you look for the denominator of a rational expression, you are always going to look for it on the unsimplified version of it. So although the last version of it here only has y plus 4 as the denominator, the domain always comes from the original rational expression. So we're going to be looking at y not equal to -1 and y not equal to -4. Next example, we're going to have x squared minus 8x plus 16 divided by 3x minus 12. The numerator here, we're looking for two numbers that will add up to -8 and multiply to 16. Those are going to be -4 and -4. And on the bottom, we realize that 3 is a common factor to all those terms, to the two terms that are there. And so we're going to have 3 multiplied by x minus 4. Simplifying out x minus 4 on both numerator and denominator, we're going to have left x minus 4 divided by 3. And if you look at this, this is actually a polynomial in disguise, right? Because the denominator here do not have any x in it. Oh, and so the domain for this particular rational expression is going to be x not equal to 4. So although it's a polynomial at the end, it still has a domain because it was originally a rational expression. Last example here, let's look at x squared minus 14x plus 49 divided by x squared minus 49. And so the numerator here is going to be x minus 7 times x minus 7. And the denominator is going to be the difference of squared. So that's going to give us x minus 7 times x plus 7. Simplifying out the x minus 7, you're going to get x minus 7, x plus 7 at the end. And of course, as usual, our domain here is going to be all numbers except for plus or minus 7. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.